Now, it's Matteo Collina. So Matteo is a technical director at Nearform. He's author of the Fast Logger Pinot and of the Fastify web framework. He has over 5 billion downloads of his open source libraries, and he's a member of the Node.js Technical Steering Committee on Streams, Diagnostics, and HTTP. He's also the co-author of the book Node.js Cookbook. It's the third edition. Teo has a huge amount of conference speaking experience and always speaks with a huge amount of enthusiasm. So now he is going to answer the question, can we double HTTP client?
Hi, everyone. Hello. Sorry, last minute hiccup. I don't know what's happening with my headphones. They keep going away all the time. Anyway, I am back without headphones. Hopefully it won't interject too much. Cool. Okay. Hi, folks. Hi, Katie. Thank you for having me and for the nice word to introduce me. Hello. Great. So hopefully you will be starting to hear me. You will hear me fine. Quick question. Is the screen sharing going? I can't hear you if you're speaking, right? So, yeah. Okay. Perfect. Yay. Okay. Amazing. Thank you, folks. Hi, everybody. I'm Matteo Collina at Matteo Collina on Twitter, and I'm here to talk to you about the HTTP client, which is pretty interesting piece of thing inside Node.js, inside every Node.js application. So first of all, let's talk a little bit about me. I am a member of the Node.js Technical Steering Committee. I created a couple of nice libraries called Fastify and Pinot. I am also doing software architect for most of my careers, and then a consultant at Nearform, which I am also a technical director of, similar to Katie. So here we go. A little fun thing about me, my modules are used quite a lot. I maintain a significant chunk of the ecosystem. These are projected 5 billion downloads 2020. It's mind blowing. Lot of responsibilities. So this is to show you the duality of my role. I help companies building fast and scalable Node.js application on one side, and on the other side, I help companies maintaining. I help the Node.js project, and I maintain a part of the ecosystem, which is pretty cool, really nice. So, and it's this kind of balance. It's always should I, how much I help companies and how much should I do maintaining Node.js and its ecosystem, and where can I leverage my learnings as a consultant to improve the ecosystem. Well, I tend to do this all the time. It's kind of a virtuous circle that I've been at for the last few years. So here we go. One of the clear architecture that you can go for the web is to have a monolith application. So you have a client, you have some link to the cloud, and then a server. This client can be a browser or a mobile app or whatever. And you have this is a monolith because it's only a single block. Cool, right? It's just one single thing, one single server, or well, more servers, but scales horizontally. It's one single code base. This is the typical, what is called a monolithic approach. It's a monolith. I have been working a lot in how we improve Node.js servers over the years. And one of the fastest, I created Fastify for this exact same purpose, to be one of the fastest web framework for Node.js, but also have a very, very nice developer experience. And you can see that it's all like modern stuff. And it's also downloaded a lot. It has a lot of collaborators, and it has a thriving ecosystem of plugins that you can use about it. Pretty nice. But you can use Node.js to build a monolith, and then what happens? You want to scale teams. Now we have been on a long debate recently on Twitter why microservices, and microservices are in fact a great way to scale teams, which is really, really cool. In fact, I can take some responsibilities and divide it into multiple microservices, which can be managed by multiple different teams, which gives us a huge, which gives us benefits, because then I can have multiple people working on things multiple times. Now, when I have too many people working on the same code base, nasty things start to happen, so you might not want to do that in the first place. Bunch of nice. One of the problems, though, about microservices architecture is that, well, you wanted to do this, right? You have a gateway and then you call a bunch of microservices. However, as soon as you start building microservices, you want to really reuse the other microservices to build more microservices. So you start having like internal microservices that are only there just to serve and share data between like the ones that are like top level ones. So, and you see that there's a lot of chattiness between the microservices. You have internal links between the microservices where they start talking to each other. Now, one of the greatest language that you can use for doing that is HTTP. And you can also use other things like gRPC, but it's, or something custom even. But HTTP is a great solution because it offers greatest traceability. You can use something like open tracing and other things to trace things up. Well, the problem is, like, I focused a lot on improving the actual node, the actual server, and the serving of a request. I found that the link between the microservices become the next bottleneck. So how fast can we fetch data? Can we retrieve some information from some other microservices that can be listening on the next route? So I started wondering, how can we speed up the link between two microservices or various microservices? Well, let's start with a very, very simple server. It's a server that returns and it has a nice timeout. So I have used this as the basis for my benchmarks. So you can configure it depending on what you want. You will get a response after those amount of seconds. Now, you probably have seen the HTTP client of Node.js a lot. You have seen you get and you do http.get to do an HTTP call. You can pass some variables here, some options in there. Then you get your response, which you need to pipe to a destination, and then you can do something with the events. This type of using this API, do a new TCP socket for each HTTP request. So it creates a socket, sends the data, closes it when it's done. And it's also the basis of Axios, Node Fetch, Request, GOT, and so on, and all of them, essentially. So if you are using all of those without any specific settings, you are using this type of pattern. It creates a new TCP socket for each TCP request. Cool. Now, note that creating a TCP socket, it also requires a little bit of a round trip, okay? So essentially, you got a round trip. Note that these are taken from this book. So you can see the book at the top. I will talk about books later on if you're interested in this topic. And so this is kind of interesting because when I create a socket, means that I need to allocate something on my sender of my operating system, which will send an IP packet, a TCP packet with SYN to the receiver, which will do some other stuff, allocate it, call your Node.js, and so on and so forth, and then we'll return a SYN-ACK, and then you will return an ACK in here with some application data. It's also this system. It's also the basic of what is called TCP connection window. So if you are creating a new connection every single time, you have you enter this. What happens is that you start opening a connection. You start getting the request. The request is processed, but then the request is segmented into multiple round trips between the server. And know that this takes some. Now, the key problem here is, and where you want to, one of the key problem is that this happens because TCP has what is called a congestion window. It's built to minimize the probability of packet loss. And it's the greatest features of TCP and why you can use TCP everywhere to do everything on the web. However, and it can work from a very, very fast connection with fiber to something very, very slow, like a 28,000K baud modem. So it works on both of them, right? Note that if we keep reusing the socket, though, you will only get your answer in one single round trip, just with minimizing the latency. So if we want to ensure maximum bandwidth, we must reuse existing connections. And this is a given, okay? Remember this. If you want to ensure maximum bandwidth, you must reuse existing connections. How can we reuse existing connections with Node.js? Well, we can. And we need to specify this agent here. which you see that you want to use a keep alive connection, which means keep the connection alive, and you want to specify a max number of sockets. Now you need to really set these, otherwise things get really weird into resource allocation on your system. So set a maximum, and this is one of the key driver of performance on this type of system. So be aware. Note that this is even more important with TLS, because if you are running this with HTTPS and less with TLS connection, you are in trouble if you're not setting an agent, because otherwise you will keep recreating a full TLS context every single time, which is, again, very, very problematic. So please keep in mind and set up an HTTP agent everywhere. Let's turn. Can you still hear me? Okay. So the client calls one server with 500 parallel requests, and it's so this means that it has like 5 outbound requests for each inbound request, which is equal 100 parallel inbound requests at any given time. And it's the timeout on the server is configured for 10 milliseconds, and the client has a limit of 50 sockets. Okay. Note that the benchmark here are really dramatic. The improvement of the agent with Keep Alive is dramatic. So this is 80, by the way, 80, close to 4,000. So the improvement is dramatic. So always use an HTTP agent. You can configure the HTTP agent in a sort of bazillion ways. So check out the library that you're using, use an HTTP agent right now. Now, okay, this is the status of things. So if you're not using it, can we improve things more further? Maybe. Let's see a couple of things. So first of all, one of the key techniques is HTTP 1.1 pipelining. HTTP pipelining is a technique that allows you to send multiple HTTP requests inside the same TCP packet. And this enables you to do the processing in parallel on the other side. So in Node.js, you can do the processing of the two requests in parallel. However, the response for those needs to come in order. Node.js HTTP client does not support pipelining, unfortunately. So how can we use this? I don't know. Well, I just want to mention one problem of this. It's head of line blocking, which is kind of one of the biggest problem for this type of solution. It's because of head of line blocking, a slow request can block the processing of our system. Now, head of line blocking is a kind of a topic that was born on top of TCP networking. So in TCP, if you are transmitting multiple TCP things, TCP packets, if a TCP packet is lost, all the messages that needs to be retransmitted, because all packets needs to be received in order. Now, this means that if we in this case, if the first request is slow, then the second one needs to wait, which is kind of a big problem if you have very slow routes compared to very fast routes. So keep that in mind. Also, let's talk a little bit about the event loop, because this is our big friend. So whenever if you are executing some JavaScript, you are doing some I/O. You want to schedule some I/O to happen, so you schedule some I/O, and then when that's done, it puts an event in the event queue and goes back in. Now, the following slide is part of our Broken Promises workshop. So let's dwell a little bit on what happens inside that single event loop phase. So you have the event loop. You have the event loop that is running. Decide that there is an event for JavaScript. The event loop calls into some C++ inside Node.js, goes back into the JavaScript function, which is your code. Once that is executed, it processes all those next tick promises, micro, blah, blah, stays there for a while, then returns on the event loop. Now, it has some very, very important definitions, because this is very important because in this type of system, minimizing the time the event loop minimize the time the event loop is blocked is the key strategy to increase the Node.js throughput. So if you see in here, you see that this time the event loop is blocked. So if we want to keep doing I/O and doing fast I/O, this phase needs to happen very, very quickly. So I started working on this topic, and I've built a new HTTP client for Node.js. This new HTTP client is called Undici. Well, why Undici? Because you have HTTP 1.1, 11, which is 11, which you call it 11 in the number. However, 11 on npm was taken, so 11 means Undici in Italian. Note that Undici, so at the point of when I start working on this, the thing happened. So, this is kind of a clear reference to it. So here you go. Not that this type of picture actually makes sense for Undici, but whatever. Anyway, with Undici, you can create a pool of connections to a given host. So you specify the pool and you put in the host here. Note that it can also have a single client API, which works exactly the same. Then you do a request to the pool, passing a slash and some other blah, blah, blah. Well, this is a bad copy and paste on my side. And then you do resume and on end. Now, you can also use a lower level API, which is actually way, way better in terms of performance, which is stream. Stream actually let you return the write stream where you want to write your response. In this way, we can avoid a little bit of overhead in your code. So it's actually pretty nice. And actually very easy to use. It's a little bit less forgiving than Node Core HTTP client. But please check it out because it's amazing. So I love it. Let's see how Undici compares to Node Core. Well, we have HTTP with no agent, HTTP with agent. Undici request, which is very similar to HTTP no agent, to be honest, is a little bit better. But you see, you still want to have the keep alive and reusing of the sockets type of thing. You see that there is Undici with pipelining. So it's still using a single connection, but not a lot. And with pipelining, it's actually getting a lot of, it's actually improving the efficiency of the single connection, but not as much. Undici with a pool, slightly better than HTTP agent with a keep alive, but if you enable pipelining, it kabooms over 3 times the throughput of Node Core, which is pretty amazing from my point of view, with all the caveats of head-of-line blocking and so on and so forth. I've also done some other benchmarking, and I know my friend James Nell will probably won't like this, what I'm going to say. So I have used this module called Fastify HTTP Proxy, which is a library to build gateways using Fastify. Again, Fastify is one of my turfs, so I'm using that. Shameless plug. And I am going, so it's using for proxy requests. It can do body and header manipulation, authentication. You can put whatever you want in here. It supports various modes, so you can use HTTP1 with HTTP1, HTTP2 with HTTP2, HTTP1 to HTTP2, and HTTP2 to HTTP2 101. I've done some benchmarking with HTTP2 to HTTP1.1 to HTTP1 or HTTP2 server. And turns out that this is Node Core with an agent, and this is Undici. You can see that the gap is pretty much, there is a lot of that can help a lot with the throughput. Note that it's also slightly better than HTTP2 with one single connection. I think we are hitting at this limit. We are hitting, HTTP2 is fully multiplexed. So it's reusing some. So it enables you to run multiple requests in parallel over the same socket. And I have a feeling that this is happening because we are maxing out some operating system resource, some internal operating system resource that prohibits us to reach higher values. Anyway, TLDR from this talk, what you should remember, always use an HTTP agent, okay? Always do that. If you don't do that, bad thing will happen. It's probably the biggest bottleneck of your application. Note that Undici can also drastically reduce the overhead of your distributed system. So check it out. It's actually pretty interesting. And I also want to thank Robert Nagy that took Undici from that work that I started and brought it to the greatest status that it's right now, which I'm really proud of. So thank you, Robert. We also need help. We also need help, so we also need a lot of help. So you can take Undici, and you can take Undici. You can use Undici to build higher level clients with Undici, like Fetch or something like that, and so on. Before we finish, I wanted to talk a little bit about a fantastic book, which is by Ilya Grigorit, which I've taken some of the slides from, some of the images from. So high performance working, and it's available online for free. You can also buy the book, but it's also available online. So given that it's available online for free, read it. It's a must-have if you want to do any performance work on the web, and it's really, really important. You can also check out Fastify, fastify.io. Here you go. And there is Undici, of course, which is you can find it on the Node.js repository /Undici, and a guide on the event loop if you are interested on that. And finally, a little thing about Node Clinic if you're interested into learning more about flame graphs. Having said that, I would thank you all. I'm part of Nearform, so we are a professional services company. You've heard Kian and myself blabbering at the beginning of the conference, so rambling a little bit. And I would, if you need anything from, if you need somebody to help you for your Node.js performance problem, to your Node.js development, JavaScript in general, whatever, give us a ring. We will be very, very happy to see if we can help you. Please feel free to reach me at Matteo Collina or at matteo.collina@nearform.com.
Okay, thank you, Matteo. That was an excellent talk. It's really, I've got some questions for you, but I would also like to remind people that if you have any questions, could you put them in the Slido channel? So there's a Q&A point you can use, but there's also in the chat. So if you put anything there, we can pick it up. So I'm going to move on to the first question. So we've got a question from Bjorn. Bjorn has asked, Matteo, how do I find the correct number for the max? How do I find the correct number for the max sockets? And is there an easier way to calculate or some sane defaults?
This is a tricky one, okay? I love tricky questions. The easiest way is to benchmark, and this is the bad way, okay? You can go and, so if you put in the wrong number, it's not super bad. So you can, if you tune that number correctly, you will see a great spike, and you will be able to handle a lot more throughput. It's kind of a balance, because you want a little bit of queuing of your request, but not too much. I would more or less increase it up until it gives me any benefit on my production system. So that would be my typical rule of thumb. I typically start with like good numbers are maybe 25 or 50, and then you can go up. Note that every socket that you allocate will consume between 8 to 64 kilobytes of RAM on your system. So if you have 1,000 allocated for your agents, keep that in mind, and so on and so forth. So creating sockets actually has an impact on your operating system. So that's it.
Okay. So Brian's just come back with another question as well. So Brian says,
nice.
will Undici for HTTP2 be called Due or Verti? Oh, people, they're just trying to get me to pronounce things wrong, especially to the Italian. I'm sorry, Matteo.
You see, that's why I call my libraries with names, so people can get in trouble. So no, it won't be called Venti. It's I don't think there is a need for Venti in Node.js. It's I think our current HTTP2 API are pretty nice and pretty performant already. So I don't think there is anything to be done there. There might be some work done and to improve those API, make them more performant, make them more compatible, make them easier to use.
Okay, thanks. I'm afraid we've run out of time for questions. So
no,
thank you, Matteo.
Reach me out on Twitter, okay? At Matteo Collina. Follow me and reach me out on Twitter if you have any questions. Thank you.
He's always on Twitter. He will be there for you. So we couldn't run NodeConf Remote without our sponsors. So a big thank you to Nearform, partly for letting us have Matteo today as well. But thank you to Nearform, Microsoft, Bloomberg, Red Hat, and IBM.